So today we're going to work on solving exponential equations. So we're going to use all of our properties of logarithms to now solve our equations. So we'll go ahead and go through a few examples and you'll be able to try a few practice problems and we'll work on this more tomorrow. So our directions are to solve. And our first one we're going to try is 10 equals 5e to the 4x. And when we are working on solving exponential equations, we remember we always need to have our exponent by itself or our log by itself before we can do anything. So let's go ahead and divide both sides by 5. So that will become 2. And this is e to the 4x. All right, so now we got to think about how can we get this exponent down. So if we take a log on this side, we'll be able to, actually on both sides, we'll be able to bring our 4x down. So instead of a log, I'm going to go ahead and use a natural log because I noticed that I already have a base of e. So taking the natural log of both sides is going to then cancel out with that e. So I have natural log of 2 equals natural log of e to the 4x. And now I know that I can bring down this 4x in front. So what I'm left with is natural log of 2 equals 4x, and then natural log of e. We remember that when the log has the same base as what we are taking the log of, that this just equals 1. So I know that this expression goes to just 1. So now I'm almost there. I'm almost to something that I can actually solve. So I have natural log of 2 equals 4x, and then I'll divide both sides by 4 to get x by itself. And this is where I'll get my calculator out, and I'm going to type in, I'm going to find my natural log button. I'll type in natural log of 2, and then I'll divide that whole thing by 4. So it might be helpful to just type this in first, press enter, then divide by 4. Or you can use parentheses on your calculator. This should be about 0.173 for our answer. All right, so our strategy we used was isolating the exponent and then using the idea that this e will cancel out with natural log. And then we took the natural log of both sides. So let's go ahead and try another one. Our next example, we're still solving. And let's see, we will say 2e to the x minus 1 plus 5 equals 80. So if you want, you can go ahead and pause the video and try it on your own and then check your answer with mine. So if you pause, hopefully you have the opportunity to try solving. And remember, before we use any kind of properties of log, before we do anything with this exponent, we need to isolate it. So we have to get rid of that 5 and the 2. So we're going to subtract 5 from both sides. And we get 2e to the x minus 1 equals 75. And now I'll divide both sides by 2. And then 75 divided by 2 is 37.5. Now I have my exponent expression by itself, and then everything else is on the opposite side. And I notice I have base e. So just like I did in the previous problem, I'm going to take the natural log of both sides. And that's going to turn into the natural log of e to the x minus 1. And then that's going to equal natural log of 37.5. So just like before, I'm going to bring down the entire exponent. So you can put it in parentheses and bring it down in front. So it's going to be x minus 1. And then I'll rewrite everything else. Natural log of e, natural log of 37.5. So remember, this expression goes to 1. And so we're left with x minus 1 equals the natural log of 37.5. And then we'll go ahead and get x by itself by adding 1. And we get x equals a natural log of 37.5 plus 1. And this is again where our calculator will come into play. We'll plug it into our calculator and we get 4 0.624 for our approximate solution. So try to refrain using your calculator until the very last step. So we don't want to have to carry these decimals, in all of our work. So round at the very last step, and then we only have to round once, which makes our answer more precise. All right, we'll go ahead and try one more. And again, our directions are to solve. And we're going to use, excuse me, not an E, it's a 6 this time. 6 to the 3x equals 12. All right, so this one's a little bit different. And if I scroll back up to my other problems, I notice that the other problems both have this base of E, which helped because then I was able to take the natural log and that would cancel out nicely. So this one I'm going to maybe use a different strategy. And you can still use the natural log, but we're not going to have it cancel out because we have a 6 here. So in this case, our goal is to still bring down the exponent so that we can solve, right? Our goal is to solve for x, and right now, x is in the exponent position. So we need to bring down the exponent. The way that we do that is we use logarithms, because then we can use our power property to move that exponent out in front. So the way we're going to achieve this goal is we can either take the log of both sides, because remember we have a log button on our calculator, or we can take the natural log of both sides, because we have a natural log button on our calculator. You wouldn't really want to do anything else because then we're not going to be able to evaluate our answer. So since we use natural log in the other examples, I'm going to go ahead and use log in this example. So I'm going to take the log of both sides, and that gives me the log of 6 to the 3x equals log of 12. And so now, since I have a logarithm expression, I can bring my exponent down in front. So I get 3x log of 6 equals log of 12. So just like before, I can isolate x. And remember, log of 6 is just a number, log base 10 of 6. So it's not going to cancel out, but this is still a number that we can move to the other side, just like we would with any other kind of equation. So we have a 3 and a log of 6 that we want to move. So I'm going to go ahead, just so you can see it, I'm going to rewrite this. And I'll put my x in front just so you can kind of see what we're doing here. So now I can divide both sides by 3 log of 6, divide by 3 log of 6. So my 3's will cancel out and my log of 6 will cancel out. So my exact answer for x is log of 12 over 3 log of 6. And this is where I pull out my calculator and I type in log of 12. Then I divide by this whole expression. So you might have to use parentheses for this bottom part. So put parentheses around 3 times log of 6, and you should get about 0.462. All right, so today you have just, let's see, a few homework problems to practice, and then we will work on this more tomorrow. So work through, check your answers with the key as you go, and bring questions to class tomorrow. I'll see you then. Bye.